In this video, we are going to talk about recursion. So first off, a recursive method is a method that calls itself. So up until now, we haven't really dealt with that much, but just as an example here, you can see in this class, I have this method called countdown. So this is the method header for countdown, and then the method body, right, is from here to here. And then inside the method body, you can see that on line 13, there is a method call to countdown itself. So inside the method body for countdown, there is a call to itself. All right, so that is a recursive method. It calls a method that has a call somewhere in its method body to itself. Okay. So programming with recursive methods is called recursion. So if you hear that term, right, it means using a recursive method to solve some problem. And recursive methods can be used to iterate or repeat an action. And it's very similar to a loop, right? Because that's what a loop does. It repeats some block of code, right? Usually using the loop for iteration is more efficient than recursion, but there's just some problems that are easier to solve using recursion, right? Generally, those problems are more complicated types of problems, but there's just some solutions to kind of complicated problems that when you look at it in terms of recursion and recursive methods, they become very, very simple to implement. Okay, so usually using a loop is the faster way, but just sometimes, right, using a loop is not the easiest thing to do, and you'll have a simpler way to implement something using a recursive method. All right, so let's take a look at this countdown.java program more closely. Let me increase this to a larger number here. And when I run it, right, all it does is count down from 10 to 1, okay? Or whatever number is in here. So whatever number I put in here, if it's a 5, right, it will count down from 5 to 1. And all it does is print those numbers from whatever number you have as the initial input, and then it will decrease by 1, okay? So that's all the program does. And before we go into a deeper analysis of this, let's take a look at the 3 properties that we need for recursive methods. All right, so generally speaking, a recursive method has the following 3 properties. Number 1, there has to be a recursive call. The method has to call itself. We've already pointed that out. For this countdown method, the recursive call is on line 13. Inside the method body of countdown, we can see the method calls itself. All right. Next up, the recursive method needs a base case, and that basically is a condition that will end the recursion. Okay. So the code that applies to the base case, right, it should not make that recursive call. So in this example with countdown, right, the base case is with 0. So if I change count and calculate countdown of 0, right, and I'm going to compile that and then run it in Canvas so you can see, Control Shift R, right, and we are going to trace through here step by step. So here we see countdown of 0, so that's going to pass a 0 into that variable x, right, and then it's going to check this condition, right. So right now the value of x is 0, so we have if 0 is greater than 0, and that is false, right? And so it's going to completely skip this block of code, right? So boom, you can see it just skips that. So in this case, with an input of 0, this line 13, that's the call back to countdown, right, where it calls itself, that's completely skipped. All right, and so that's what's going to happen in the base case. This call to itself, or any call to itself, is going to have to not be executed. All right, and you can see from there what happens is that method ends, and then the main method ends. So in that case, essentially nothing gets done with a 0. Okay, so that is the base case. The recursive call, or any recursive call, the call to itself gets skipped in the base case, and so that will end this recursive process. All right, and then the third requirement that you have is the reduction to the base case. Each recursive call reduces the previous input, bringing it closer to the base case. Okay, so what happens here is that if let's take a look at what happens when I do countdown of 1. All right, so compile that and run it. You can see that's what I get, just 1. So let's take a look at how it works through Canvas. Okay, so I'm going to call countdown of 1, right? And I am going to step through this so you can see what happens. So the countdown method gets called. All right, so right now the value of x is 1. Okay, and then here what's going to happen is that this condition is going to be checked if 1 is greater than 0, and now 1 is greater than 0, so therefore this condition is true, so it's going to fall into this body of the if statement, right? Execution, and that is going to print the 1, and then I am going to call the countdown method itself. So here is where the method calls itself. You can see in this case, right, I don't just call it with x, right? But I call it with x minus 1. So that means I subtract 1 from x, and so that will be 0. So this is the part where the input gets reduced, right? So whatever number is coming in as the input, if it's not 0, then we're going to subtract 1 the next time we call it. Okay, and then that's going to eventually, right, be reduced to 0 if I start with a positive number. Okay. All right, so here is the recursive call. You're going to see it's going to bounce back into countdown itself, right? So it bounces in, and it's going to check. See, now x is 0 here, even though it's showing as 1 here. Okay, and now it skips it. Okay. All right, it is a little strange, right, to see how this works. Okay. Even when we're tracing through, right? And so to me, it really, really helps if you draw this out and see what's going on. So trace it out by hand, and that's what I'm going to do, right? So I'm going to start with, say, countdown 3, all right, in that method call. All right, in countdown 3, when I do countdown 3, right, what's going to happen is that you're going to get this code in here. So if 3 is greater than 0, then we're going to print 3, and 3 is greater than 0, right? And then we're going to do countdown 3 minus 1, which is 2, right? That's what happens here. So x is 3, right? So I print 3 out, and then I call countdown with 3 minus 1, right? So that's what's happening here. So now that's going to call countdown with a 2, right? So now a new method call is made, right? And so that 2, right, comes from here. Let me draw that in red. So this 2, right, is getting sent up here into this countdown method. All right, and then a new instance of that method, right, is getting run. So with x being 2, so it's if 2 is 0, right, then it will print, and that is true, 2 is greater than 0. So it will print 2, and then it will do countdown. So here is where the method calls itself, and it's going to call it not with 2 but 1, right, because of this x minus 1 right here. All right, and so then a new instance of the method is going to get done, and right, this one comes from this one here. All right, then we run through the method body again, this time with x being 1, right? So if 1 is greater than 0, right, then which it is, right? So we print 1, and then we call countdown again, right? And this time we call it with 0, okay? And so you can see it just kind of keeps working its way, right, through these method calls. Each time the method gets called, you can see the input, right, is closer to the base case, which we said is 0 here, right? So that 0 is right here, okay? All right, and then on this one, right, it's if 0 is greater than 0, well, that's false, right? So nothing is done, right, here, okay? So nothing gets printed out. So you can see what gets accomplished, right? And that basically ends it. There is no recursive method call being made, right? Because this essentially does nothing, right? Because this is false right here. All right, and so this method returns, right? Then this method returns, then this returns, and then this returns, like here. And we wind up with 3, 2, 1, like that. So to me, right, recursion is hard to understand if you don't take the time to think about this process and write it down and trace through and figure out how it works, okay? Okay, so that is the basics of recursion. Now what we're going to do is now do a bunch of different problems, and we're going to separate those out into videos of their own, each problem, so it's easier to refer back to.